x plus 1 times x plus 3 times x plus 4 times x plus 6 equal to 72. You know, we can still expand this. We expand it, the highest power will be x to the power 4, just like the other one. But let's not go through that long process. Now, I'm going to start solving this by rearranging. Grouping, taking this and this together first. So that will be x plus 1 times x plus 6. Okay? Then, go on with the other two. Say x plus 3 times x plus 4 equal to 72. Now, the reason for this equal to 72. The reason for this is I want, when we are expanding, the middle term, okay, should be the same in throughout. Now watch. So expanding this, we're gonna have x times x, x squared. This times this, that is plus 7x plus 6. Okay. In this other method, in this other product, you're gonna have x squared plus 7x plus 12 equal to 72. So that's the first thing. Okay. Now you watch that this and this are the same. So I say let x squared plus 7x be, let's make it t, be t, so that we have t plus 6 times t. Right? Let's not confuse you. Times t plus 12 equal to what? 72. So we have that t plus 6, let this be t. So we have t plus 6, here is the same thing as this. T plus 12 equal to 72. Now we can expand that. Expanding this, we're going to have t squared plus 18t plus 72 equal to 72. Okay, that means t squared plus 18t is equals to 0. So we can factorize, since t is common, we have t plus 18 equal to 0. This implies that t is equal to 0, or t is equals to negative 18. It's either t here is 0. You have a product of two numbers, a and b, equal to 0. Why? It's either a is equal to 0 or b equal to 0. That's very true. The product of two numbers cannot be 0 if at least one of those numbers is not 0. So we don't know which of them is really 0. So we assume it's either this one is 0 or the second number is 0. So it's either t is 0 or t plus 18 is 0. And if t plus 18 is equal to 0, that means t equals to negative 18. How? Now recall that recall that t was equal to what? X squared plus 7x. X squared plus 7x. So since t was equals to x squared plus 7x, then we say that when t is equal to 0, that means x squared plus 7x is equal to 0. This means x times x plus 7 equal to 0. So that means that x is equals to 0 or x is equals to negative 7. These are the first two solutions to x. Remember, if you were to expand this directly, we would have had x to the power 4. So since the x power is 4, that simply means that we're going to have 4 solutions. So here is either x is equals to 0 or x equals to negative 7. Now, when t is negative 18, okay, this means that x squared plus 7x will be equal to negative 18. Okay, that means we're going to have x squared plus 7x plus 18 equal to 0. Okay, can factorization method works here? Let's use the quadratic formula method. So using that, we're going to have x is equals to negative b, that is negative 7, plus or minus square root of b squared, that's 49, minus 4 times a times c, that is minus 4 times 18, over 2 times a, that's 2. Okay, now this should be equal to, that means x is equals to negative 7 plus or minus square root of 49 minus, already this will resolve to a complex number. We would have 4 times 18 to be 40 plus 28. Okay, sorry, 40 plus 32, that is 72. 4 times 18. You have 2, you have 72. You have a negative 72. This resolves to a complex number. So this means that x equals to negative 7 plus or minus square root of 49 minus 72. That should be 33. No, 33. 49 plus 33. This plus this. Okay, that's 23. That's 12. Okay, so that's 23 over 2. So x is equals to negative 7 plus or minus square root of 23 over 2. So those are another two values of x. Therefore, in this question, the values of x are, say, x is equals to, the first two values were, x equals to 0, comma, negative 7, comma, negative 7 plus or minus square root of 23 over. Sorry, this is negative 23. Negative 23 is a complex number, so negative 23 over 2. These are the four values of x. Alright, so fixing these values, each of them, it would agree with this equation. I hope that's okay. First thing, we are going to group this x. We are going to group them such that the powers of x would be the same. Look, let's start here and here. You know the power of x here is 0, so that will be x to the power 4 plus 1. That's how we group it first. Next is that we're going to take this and this. that should be plus x to the power 3 plus x. And lastly, the only one left is negative 4x squared is equal to 0. Hope that's not confusing. We take this and this, take them together, x cubed and x. Then the only one left is to the second power. We keep it there. Now, from here, we're going to solve, I would say, let's divide through by x squared. So we divide through by x squared. That means this divided by x squared, this divided by x squared, divided by x squared, divided by x squared, divided by x squared. 0 divided by, everything divided by x squared. Alright. Now we divide everything by x squared. So let's evaluate, let's simplify that. That should be x squared plus 1 over x squared plus x plus, this will go with the first power here, so we have 1 over x minus 4 is equal to 0. So this is what we have next. Now, I can do this. All right. Let me make a statement. Let x plus 1 over x be t. Let this middle term be t. Let it not be bet, be t. Be t. Okay. Now, if the middle term there is t, okay, so we can say, so t is equal to what? X plus 1 over x. Very good. So t is equal to that. Then t squared will be equal to what? Will be equal to this squared, because t is something like this. So to be equal to x plus 1 over x squared. Now, let's expand this. So, expanding this, we're going to have x squared. Hope you know about your binomial expansion. We've made a video on that. X squared plus 2 times x times 1 over x plus 1 over x squared. Now here we would have to be equivalent to x squared plus 1 over x squared. Now x cancels x plus 2. So we can make a statement by saying that t squared is equal to x squared plus 1 over x squared plus 2. So if t squared is this, then, and you could observe that this is something like this. So what is x squared plus 1 over x squared? 1 over x squared plus x squared is equals to t squared minus 2. That's the value for this. So if x, we say let t be this, such that this, such that, this be t, such that this will be t squared minus 2. So we can continue. We say t, t squared minus 2 plus t squared minus 2 plus t minus 4 equal to 0. So t squared plus t minus 6 is equal to 0. You seen that? So we can now see we've arrived at a quadratic form of equation. Let's continue. I hope you can solve from here. Now, let's take two factors whose product would give us negative 6, and no sum will give us positive 1. That is, at once it is 3 and negative 2. We want to use factorization method to solve this quadratic equation. 3 and negative 2, 3 times negative 2, okay, and plus will give us what we want. So at once we have t plus 3 times t minus 2 equal to 0. So t is equal to negative 3 or positive, or t equals to 2. So these are the two values of t for which this particular equation, quadratic equation, is satisfied. Alright, we are not yet through. You can recall that t was equals to what? Recall t was what? So t was this. So we call that t was equals to x plus 1 over x. Now we say when t is equals to 2, okay, when t equals to 2, then what will be x plus 1 over x? It will be 2. T is equals to x plus 1 over x. T equals to 2, therefore this and this are equal at once. Now that's what we call relations. Under relations you have that. Now we can solve this. Simplifying this, we have taken the LCM here, of x and 1. We're going to have x, have here x squared plus 1 is equal to 2. X squared plus 1 equal to 2. Okay, let's go on. So that means that we have x squared plus 1 is equals to 2x. So x squared, this arises as another quadratic equation, minus 2x plus 1 equal to 0. Looking at this, let's use let's use factorization method. So which two factors satisfy this? That should be negative 1 and negative 1. Their product will give us positive and their sum will give us negative 2. That is okay. So the two factors are negative 1 and negative 1 equal to 0. So we put it this way. We now say x is equals to 1 or 1. So x is equals to 1 twice. So the two values of x are 1 and 1, for which this equation is satisfied. So the first two values of x are 1, 1. We're still left with other two. This is a solution. 1, 1. We're still left with other two solutions. Okay. Now, when t, when we're solving this, we're solving when t was 2. Now, when t is 3, okay, what do we have? We would have that x plus 1 over x is equals to, was it 3? Negative 3, sorry. When t is negative 3, equal to negative 3. So we would have x squared plus 1 is equals to negative 3x, just like this other case here. Then we have the x squared plus 3x plus 1 equals to 0. We're going to solve for that. Seeking two factors. Okay, looking at this problem, looking at this equation, factorization method won't work here. So we're going to make use of the almighty formula method, the quadratic formula method. You can see it's already too much, but very simple. So making use of the quadratic formula method, let's say x is equals to what? Negative b. Our b is what? 3. So negative 3 plus or minus square root of b squared, 3 squared is 9, minus 4 times a. 4 times a is 1, times c 1. So minus 4 times 1 times 1, that is 4, over 2 times a. 2 times 1 is 2. So we have x equal to negative 3 plus or minus square root of 5 over 2. So these are the two values of x. So we say x equals to negative 3 plus square root of 5 over 2, or x equal to negative 3 minus square root of 5 over 2. Therefore, so these are another two values of x for which this equation is satisfied. So therefore, plus or minus negative 3 plus or minus square root of 5 over 2, or this. Okay. So therefore, x is equals to 1, 1, negative 3 plus or minus square root of 5 over 2. These are the values of x for which this equation is satisfied. Hope that's clear enough. All right. And now is our final question. Let's look at this question, this equation, okay? Now, let's start at once. I am not going to find the LCM at first, the LCM of these two denominators. What I'm going to do at first is that I am going to rearrange this by splitting the fraction. Now, let's split these fractions by first saying x plus 2 plus 1 over x plus 2. Okay? In place of 3, I split it 2 and 1. So, 2 and 1 plus x minus 2 minus 1 in place of 3, x minus 2. Okay, which is equal to, now, observe something there. 2x minus 3 could be split to 2x minus 2 minus 1. Now, if I take this and this, I can simply factorize 2. So factorizing 2, I will have x minus 1 outside. So I split it, minus 2 and negative 1. Then now factorize, taking 2 out, I will have that left. So that's what I'm going to have here. So we have here 2 bracket x minus 1 over x minus 1. All right. Now in the next step, let's rearrange, or let's split the fractions like I said. So let's cancel. This can cancel this. So you're going to be left with 1 plus 1 over x plus 2 plus this can cancel this. So we'll be left with 1 minus 1 over x minus 2, which is equal to this can cancel this. So we'll be left with 2 minus 1 over x minus 1. Now, looking at this, we see here that 1 plus 1 resolves to 2 plus 1 over x plus 2 minus 1 over x minus 2, which is equals to 2 minus 1 over x minus 1. Okay, seeing these numbers, 2 and 2, we can say that 2 and 2 goes. Okay, now if you subtract 2 from both sides here, this place will be 2 minus 2, that will be 0, or the other way, but to resolve to 0. So we have remaining, we'll have x plus 2 minus 1 over x minus 2, which which is equals to negative 1 over x minus 1. Now here, let's take the LCM of the left hand side. So taking the LCM of the left hand side, we have x plus 2 and x minus 2. Okay, here we can now do our normal evaluation. So here we divide, here divided by the numerator, that will be x minus 2 times 1, x minus 2. This LCM divided by the denominator, this will cancel, so we have x plus 2. So x plus 2 times 1 is x plus 2. Remember, this is negative. Okay, is equals to negative 1 over x minus 1. Now, we can go on. Now, I want you to look at this problem. This is a particular step. What do you think our next step would be? Okay, at first, we are going to simplify the numerator. Here we would have x minus 2 minus x minus 2 over, let me keep there. I want you to think of something, minus 1 over x minus 1. Okay, so what do you think the numerator will be? You know, we have x plus 2 and x minus 2. That should simply take us to difference of two squares. So we're going to have x squared minus 2 squared. That's 4. Minus 2 squared. If we expand this, x squared plus 2x minus 2x, that's 0. Okay, alright. Let's completely simplify the numerator. We have x minus x is 0. Negative 2 minus 2, that's negative 4. Over. Remember, this took us down here. Okay, negative 4 over what? Negative 4 over x squared minus 4. 2 squared is 4. Equals to negative 1 over x minus 1. We can now cross multiply. By cross multiplication, we have negative 4 times x minus 1, which is equals to negative 1 times x squared minus 4. Okay. Expand this, we have minus 4x plus 4. Okay, equals to negative 1 times x squared is negative x squared. Negative 1 times negative 4 is positive 4. Alright, we are almost there. And mind you, this is negative 1 times x squared is negative x squared. Okay, we are heading to the end. Now, let's rearrange in descending powers of x. Let's take x squared. Let's eliminate x squared here and make it appear on the left hand side. That is by adding x squared to both sides. That would become x squared minus 4x, okay, plus 4 is equal to 4. So once we see that this and this can cancel out, 4 and 4 can cancel because the both of them are positive and on different sides. Okay, so due to that, we have here x squared minus 4x is equal to 0. Is equal to 0. Since this is equal to 0, that means that factorizing, you take x out. That will become x. Since x is common, that will become x minus 4 equal to 0. Therefore, x is equal to 0 or x is equal to 4. So these are the two values of x. X is equal to 0 or 4. So with x being 0 and x being 4, then this equation is satisfied. And I believe you had known from beginning that for each of these fractions, okay, x cannot be negative 2, x cannot be positive 2, and x cannot be 1. Because if x was any of these, negative 2, 2 and 1, negative 2 you make this place 0, and the denominator being 0 in a fraction, it approaches infinity. Because of that, it makes everything undefined, not to be defined as well. But these two values of x, if we want to testing for these values, let's say we have 4 and 0. When x is 0, this will become 3 over 2. When x is 0, yes, become negative, plus 3 over 2 minus 3 over 2 divided, minus 3 divided by minus 2, that is 3 over 2, which is equal to, when x is, we're testing for 0, 0 here, 2 times 0 is 0, negative 3 over negative 1, that is 3 over 1, that's 3. Okay, now looking at this, 3 plus 3 is 6, 6 over 2 is 3, and that satisfies with that. That is if x was, when x is 0. Now when x is 4, you can also do that for yourself. You will see that the left hand side, the right hand side will be the same. That has brought us to the end of some of these, like I said, headache giving problems under polynomial equations, where you don't need to go through polynomial fractions or to look for the factors from which this equation will be equal to 0. You just have to play with it, and you simplify and you get what you want. All right, thank you. Now get ready for our next video.